Okay, so we have another string dealing with ratio tables, and bear with me, sorry. We're going to look at how we can actually use the ratios to make these problems much easier, to simplify them in a way that just helps us out. So we'll highlight 3 problems here. And the basic gist is, okay, so let's set up our ratio table. And we can have cans of paint on the wall or anything like that. But let's just say, for example, we have 4/10 for every 1/3. That's a ratio. So 4/10, we'll put it right in our table here, to 1/3. Can we make this any friendlier? Can we make it easier, even without context? So we have some amount of something. This could be a number of cans of paint covering 1/3 of the wall, but we can leave that a mystery for now. We don't need to know what this table is actually referring to. How do we make 4/10 divided by 1/3 much friendlier? What can we do? One strategy is to multiply 1/3 by 3, because then you have 3 1/3, which is just one whole. But you want to keep this table balanced, so you want to also multiply this by 3. And what does that give us? Well, 3 times 4 is 12, so it's 12/10. Now, that was a ratio being set up, but really, this ratio can be thought of as a division sign. So look what we've done. We've rewritten this problem as 12/10 divided by 1, which is nice and easy. So 12/10 divided by 1 is just 12/10, and that's our answer. We can simplify, divide numerator and denominator by 2, we get 6/5, and we're really done. So our strategy here in the ratio table is just to rewrite these ratios in a way where it's something to 1. Let's look at the next problem. We have, it's a different color, 4/5 to 2/3. So now we have our ratio table set up. We're not even sure what this represents, which is unfortunate, but we're trying to work without context for a moment. What do we do with 2/3 to make it easier? Can we multiply by 3? Well, yes, that would help. Let's try that. Multiplying by 3. Multiply this by 3. Now we get 6/3, which is 2, almost as friendly. And we get 12/5. Now we can still make this even easier. I mean, I don't want to work with 2, I'd rather work with 1. So multiply by 3, how do I deal with this 2? Well, can I just divide by 2? Yeah, because 2 divided by 2, that's 1. I can divide this by 2. And I guess really here, we're almost doing that problem out anyway. What is 12/5 cut in half? Well, that's 6/5, right? Cut it right in 2 6/5, and now we have this nice ratio. 6/5 to 1. And that means 6/5 divided by 1, which of course is 6/5. And notice we're getting the same answer as before. And I'll leave it to you to think about why that makes sense. But again, we're focusing here on a strategy where we're rewriting ratios, where we're dividing by 1 or 2 or something simple, not a fraction. And if you look at these 2 steps, what I think is kind of interesting, we multiplied by 3 and then divided by 2. So if you look at the fraction 2/3, well, when it was 1/3, we just divided by 3. Okay, but when it was 1/3 to get rid of 1/3, we times it by 3. Now it's something over 3, we multiply by 3 and then divided by 2. This is the idea of the reciprocal. We could have done this in one step by saying, oh, 2/3, to get rid of that, multiply it by 3, but then divide it by 2 at the same time. And that would just give us 1. So, here with 1/3, we can view it as multiplying by 3 or multiplying by 3/1. That's the reciprocal. And again, the reciprocal, we have a over b. The reciprocal of that is b/a. Reverse the numbers. And I'll show you what I mean in one more example to help clarify. So now we have 8/5 to 2/3. Well, I don't want to divide by 2/3. I want to simplify this problem. So I'm going to take 2/3 and I'm going to multiply by 3 and divide by 2 in one step. So 2 times 3 is 6. 3 times 2 is 6, and we've got 1. So that does the trick. But we also have to do it to this number. So now, what ends up happening is we have 8/5 times 3 over 2, right? We're doing the same thing to both sides. And we could do this. 8 times 3, 24. 5 times 2 is 10. Divide numerator and denominator by 2, and we get 12 over 5. So notice this problem, 8 over 5 divided by 2 over 3, to solve it, what we really did was 8 over 5 times 3 over 2. And this is, I think, starting to create the standard algorithm, which is we switch division to multiplication, and we change our fraction, our second fraction, to its reciprocal. And if you feel uneasy about this process, you can always play around with the ratio table, thinking that, I mean, of course, you could change the first number to 1 in this column, and then have 1 divided by something, which is still simple, because really you'll just come with the reciprocal, whatever value you have here, but it's just easier to have something divided by 1. So for example, 12 over 10 divided by 1, that's the answer, you're done. So the goal is always to make that second fraction into 1. So you can always flip that second fraction. And we'll look at a couple of more strings about this.